Okay, in the last lecture we learned about the first inverse trigonometric function, which was the sine inverse function, which is the inverse of sine x. Is it the inverse of the natural sine x? What do I mean by that? We learned before that there are some functions that have a natural domain and some that have a restricted domain or an imposed domain. So what is the inverse? Does this function y, if I say to you this function y equals sine x, does it has an inverse? No. Why? It doesn't have an inverse. Why? It doesn't have an inverse because it is not one-to-one, and we learned that for a function to have an inverse, it must be one-to-one. So that's why we restrict the domain of sine x in order for it to be a one-to-one function. So we restrict the domain of sine x so that it becomes a one-to-one function. So do you remember what was the restricted domain of sine x such that it becomes a one-to-one function? Can you remember? It was from minus pi over 2 to pi over 2. So that red function is called the restricted sign. Restricted sign. And that is different from the natural sign. The natural sign has a domain that is r. The natural sign has a domain which is r. But the restricted sign has a domain which is from minus pi over 2, from negative pi over 2 to pi over 2. Okay? So these are the inverse pairs. Sine inverse has an inverse which is not sine x, not the natural sine x, it is the restricted sign. Okay? And the inverse of the restricted sign is sine inverse. But if I told you what is the inverse of sine x, you can't tell me that it is sine inverse. Why? Because this is the natural sign. But if I give you a restricted sign, then the inverse is sine inverse. Okay, that's okay. If I told you what is the inverse of sine inverse x, is it the sine x, the natural sine x? No, it is the restricted sine x. What is meant by restricted sign? That it has a domain from minus pi over 2 to pi over 2. And we learned how, so these are the function from minus pi to negative pi over 2 to pi over 2, and we learned to graph the inverse function, which is sine inverse x, which has it would be something like that, okay, which is reflected about y equals x. So it gives me a curve like that. So when you look at it, the values that are on the y-axis, which are minus from negative 1 to 1, will be on the x-axis. We learned that for inverse function we switch between, or we interchange the x and y. Okay, so that's what happens to the values on the x's. When I have the from negative 1 to 1 will be in the inverse function. For the inverse function will be on the x-axis instead of the y-axis, and so forth from negative pi over 2 to pi over 2, which were on the x-axis for the sign, the restricted sign, they will be on the y-axis for the inverse function. So it will be like that. Okay, so that was the sine inverse. Let's remember some of its properties. What was the domain of sine inverse? What is the domain of sine inverse? Sine inverse, what does it what are the restrictions on the inputs of a sine inverse? It must be a value from negative 1 to 1. It must be from negative 1 to 1. So that's why when I give you some problem, if I tell you find the domain of x squared negative 1, for example, x squared minus 1. So how would I solve this problem to find the domain of this function, I take the input x squared minus 1 and put it inside the inequality from -1 to 1. Okay, and then I solve with my learned skills of solving inequalities, and I've learned that how to solve such an inequality. Okay, so that was the domain of sine inverse. So what was the range of sine inverse, or the output of a sine inverse? What was the output of the sine inverse? It is an angle which is from -pi/2 to pi/2, and we depicted that for the unit circle. It is an angle. A sine inverse is always an angle that belongs to which quadrant? A sine inverse is an angle which belongs to which quadrant? Which of these 4 quadrants are these angles from -pi/2 to pi/2? This is from 0 to pi/2. This is the first quadrant, and from -pi/2 to 0, that is the 4th quadrant. So a sine inverse is an angle which belongs to the first or the fourth quadrants. Okay. Also, we learned that a sine inverse is it an even function or an odd function or a general function? Can you remember? It is an odd function. It is an odd function. That's why we say that sine inverse of negative of any block, it will be minus of sine inverse that block. Okay, so that is the rule, and we also depicted that rule on the unit circle. If you remember, in the last lecture we depicted that rule. We saw how to graph, or how to see by our eyes, how to see this angle and this angle, and we have noticed the relation that this angle is just the negative of the other angle. Okay, we depicted that on the unit circle. So let's continue our journey on the inverse trigonometric functions. We will study the cosine inverse function. Just like how we have done in the sine inverse, we'll do it again for cosine inverse. So the natural cosine is sketched like this. This is the graph of a natural cosine. Okay, does this function, the natural cosine, does it have an inverse? Does the natural cosine, does it have an inverse? I need to hear your answers. You need to participate. No, it doesn't have an inverse. Why? It is not 1-to-1. We learned that for a function to have an inverse, it must be first to be 1-to-1. What is meant by 1-to-1? We learned before the horizontal line test. If I make any horizontal line that gives me more than one point of intersection, then it is not 1-to-1. This function is not 1-to-1. So a natural cosine doesn't have an inverse. Okay? So how to deal with this problem? How to make an inverse? How to find an inverse of this function? So we need to make a restriction in the domain. Yes. So what is the suitable restriction? What is the suitable restricted domain in this case? Should I take it like the sine inverse, or the restricted sign that was from -pi/2 to pi/2? Is this suitable in this case or not? No, this is not suitable. Why it is not suitable? Why this restricted domain not suitable for us in this case? Yes, it is. It is not 1-to-1 in this interval. The function is not 1-to-1 still. For the horizontal line test, we have more than one intersection, so it is still not 1-to-1. So this restricted domain is not suitable for us. This is not suitable for us. What about this one? What about this one? Yes, this one is 1 to 1. Okay. Yes, there is another condition that must be satisfied for our inverse function to be practical. That it needs to be covering the whole range. This restricted domain doesn't cover the whole range. The whole range of cosine is from -1 to 1. And I need my restricted domain to be covering the whole range. So this is not suitable. So I just extend it like this to be from 0 to pi. And this is the restricted domain of cosine x. So we have y equals cosine x. The restricted cosine x, restricted cosine x, which has x is from 0 to pi. X is from 0 to pi. Okay? So that is our function, the restricted cosine. Restricted cosine is depicted on a graph like this. If I need to graph the inverse function, I may make the graph by a reflection about y equals x. So I will just make it like that. This is the reflection for this part. Then there is another reflection for this part, and so on. But I may also make the inverse by the points, by interchanging the coordinates of each point, of each special point. We have, for example, these 3 special points. This point is pi and -1. This point is pi over 2 and 0. And this point is 0 and pi. So for the inverse function, we'll just switch or interchange the values of x and y's. Okay? So if we interchange the points, these points, I will just make an interchange the points on the x-axis. I will just put them on the y-axis. So I'll just put this to be pi, 0 to pi on the y-axis, and from -1 to 1, I will just put it on the x-axis like this. Okay. Now let's check or interchange the coordinates of each of these points. So I'll have a point which is, instead of 0 to pi, 0 and pi, I will have a point which is pi and 0. Pi. No, this point is 0 and 1. This point is 0 and 1. Okay? So I'll have a point which will be 1 and 0. So this point will be reflected on this one. Okay? The interchange of the coordinates will just be this point. Okay? And for this point, I will have 0 and pi over 2. So I have this point. This is another point. Also, I will have -1 and pi. -1 and pi. This is another point. Okay? So just my graph will be something like that. My graph will be something like that. Okay? So that is the curve of cosine inverse x. What is the inverse of cosine inverse x? What is the inverse of cosine inverse x? I need to hear your answers. Yes, the restricted cosine, not the natural cosine, the restricted cosine. Okay? The inverse of cosine inverse is the restricted cosine. Okay, let's write the domain and range of cosine inverse. What is the domain of cosine inverse? What are the restrictions on my input of a cosine inverse? It must be from -1 to 1. It must be from -1 to 1. Okay? What is the output of a cosine inverse? It must be an angle from 0 to pi. It must be an angle from 0 to pi. If I depict that on the 4 quadrants, what is an angle from 0 to pi, they belong to which quadrants? The first and the second quadrants. They belong to the first and the second quadrants. Okay? So a cosine inverse, an angle which is called a cosine inverse must be or must belong to the first or the second quadrants. Okay. What about the symmetry of this function? Is it an even function or an odd function or a general function? Look at this graph. What do you think this function is? Is it an even function? Is it symmetric about the y-axis? No. It is obviously not symmetric about, so it is not an even function. Okay? So although the cosine itself is an even function, we know that the cosine is an even function, but its inverse is not, it is not even. Is it odd? No, it is neither odd. Why? There is no symmetry about the origin. If it was symmetric, if it was odd, it must be symmetric about the origin, and this is not the case in this graph. So this function is a general function. It is neither even nor odd. It is neither even nor odd. Okay? And this in general is the case for even functions in general. Why? What is the symmetry of an even? If I have some even function, what is the inverse of an even function? What is the inverse of an even function? What do you think it would be if I have an even function like this and I need to find the inverse? What do you think the inverse will be? Would it be an even function or an odd function or a general function? An even function has no inverse. An even function has no inverse. Why is that? Why do you think an even function doesn't have an inverse? It is not y to 1 by its nature. You say that an even function is symmetric about the origin, so naturally and the horizontal line test will not be satisfied. Whenever you have a point on the positive side, you will have just a symmetric point like it in the other side. So an even function is not invertible. An even function is not an invertible function. It doesn't have an inverse. Even if you restrict the domain of an even function like we have just done for a cosine function, we may restrict the domain of an even function like this, for example, or this, maybe like this. This, you just remove the negative part of the function so that you can find an inverse. You restricted the domain in some way. In this case, what would be the inverse? This function may have an inverse, okay. But what would be the symmetry for the inverse of this function? Would it be an even or an odd or in general? It will be a general function. So a restricted even function will have an inverse which will be general. Why is that? Because it doesn't have a negative side. Even functions and odd functions always have a symmetric domain. Even and odd functions always have a symmetric domain. So whenever you have a function that is defined only for a part of the, or for a positive side only or a negative side only, it is not symmetric. The domain of self, if the domain of self is not symmetric both sides, it is general directly. I can decide immediately that it would be general. For example, the case for a root x. I don't need a check for root x. Why? Because the domain is on one side. And this is not a symmetric, this function doesn't have a symmetric domain. So directly it would be, I would say that this is a general function without any check I don't have a negative side for this function. How to check the symmetry if I don't have a negative side? I don't have a negative side, so it would be a general function. Okay? Now if I, let's check this problem. Find the range of y equals 3 cosine inverse 2x. We learned a method before to find the range of a function. Do you remember how did we manage to find a range? That was one method to find a range. That is to find the domain of the inverse of this function. Okay? It was to find the domain of the inverse of that function. I have skills, I have earned some skills that make me know how to find the domain, but not the range. So how would I solve a problem of a range? I learned that the inverse function interchange the domain and range. Interchange the domain and range of, so the domain of f is just the range of f inverse, and the range of f is just the domain of f inverse. Okay? So one way to solve this, I will just solve it in another way. There will be an alternative method in this, but just let's solve it by the way that we have learned. The method what we have learned is to find the inverse of this function first. We need first to find the inverse of this function. Okay? How to find the inverse of this function? We learned how to find an inverse of a function. We learned 2 steps: to interchange x and y and to solve for y. Okay? Or you may do it in another order for the steps. You may solve for x first, then interchange x and y. Okay? So we may do it by this way or this way. This one is more suitable for if I have the given function is not 1-to-1. If the given function is not 1-to-1, it may be more suitable to solve it like this. Why? Because in this case the restricted domain will be more obvious. It may also be solved by this way, but in this method the restricted domain will be more obvious by these steps. Okay? Cosine inverse, is it an 1-to-1 function or not? Cosine inverse, is it a 1-to-1 function? Yes, of course it is a 1-to-1 function. Any inverse function is a 1-to-1 function. It is an inverse function. Any inverse function, a function that has an inverse is a 1-to-1 function. A function that has an inverse must be a 1-to-1 function. Okay? So we have just derived the cosine inverse from a 1-to-1. It is by itself an inverse function. So by nature it would be a 1-to-1 function. So I will just interchange x and y for this problem to find x equals 3 cosine inverse 2y. Now I need to solve for y. So I need to put y alone on a side and other variables on the other side. So I will just get rid of this 3, I will just divide by 3. Now I need to get rid of this cosine inverse. How would I cancel this cosine inverse? By operating the inverse of this function both sides. Okay, that is exactly what we have done the inverse for. The inverse function is just a function that inverts the operation of a given function. So I just need to cancel this function, I will just operate by cosine both sides. But we need to notice here, for this to cancel this one, for the operation of the cosine to cancel this one, is this the natural cosine? Is this the natural cosine? No. What are the inverse pairs of each other? The cosine inverse and the restricted cosine, not the natural cosine. So this is the restricted cosine. This is the restricted cosine. Okay? So in this way we'll have 2y will be equal to cosine, which I will just notice that it is a restricted x over 3. So that's why y will be equal to 1 over 2 cosine x over 3 restricted. And that is exactly the inverse function of the given function. That is the inverse of the given function. Okay? Now let's find the domain of this inverse. Let's find the domain of this inverse. The domain of f inverse will just be, this is the cosine restricted. This is the cosine restricted. So I will just take what is inside the cosine. What is the domain of a restricted cosine? It is its restricted domain, which is from 0 to pi. So I will have x to be from 0 to 3 pi. And that's why the domain of f inverse will just be 0 to 3 pi. The domain will just be from 0 to 3 pi, which is exactly the range of the given f. Which is exactly the range of the given f. Okay? That is one way to find the range of this function. But for this problem, I may have another method, and this is suitable if the input of the cosine is a linear function. I have just learned that cosine inverse is a function which is its output is from 0 to pi. Now this is the required. We need to find the range of y equals 3 cosine inverse 2x. Now we learned that cosine inverse is a function which has its output will be from 0 to pi. A cosine inverse function has an output which is from 0 to pi. But I need to know what is the range of a function. A range of a function is the set of all outputs. So I just need to know the output of this function instead of this. So what would I modify, or how would I modify this inequality to be in this form? How to know the range or how the output, the set of, or the inequality for this form? I will just multiply by 3. I will just multiply by 3 in this way. So that will be from 0 to 3 pi. And this is exactly y. This is exactly y. So this inequality, from this inequality I have derived that, or I have deduced that y would be, which is the outputs would be in the interval from 0 to 3 pi, and this is exactly the range of this given function, from 0 to 3 pi. Okay? So that is another way to find the range of a given function. You may, from knowing the properties of that function, you may find the range of some other modified form of the given, of the known function. So we learned that the cosine inverse, is it an even function or an odd function? Cosine inverse is a general function. So would I say that cosine inverse of minus alpha, would it be cosine inverse alpha, or would it be minus cosine inverse alpha, or would it be neither of these two? It would be neither of these two. It wouldn't be this one, or would it be this one? It is not equal to any of these. Why? Because it is not even nor odd. It is neither even nor odd. Okay? So it doesn't satisfy the rules for even and odd functions. But what is the relation between this angle, which is cosine inverse negative alpha, this is some angle, and this other angle? We need to know the relation between these two, and we will deduce a rule or a law that relates both of these two angles. So let's depict these two angles on the unit circle. Just remember that an angle which is a cosine inverse must be in which quadrants? They must be on from 0 to pi. Any cosine inverse must be from belong to the first quadrant or the second quadrant. Okay, let's just put that in mind when we are doing our steps now. Let's first depict that angle. This is an angle which has a cosine which is equal to alpha. What is meant by an angle that has a cosine equal to alpha? It means that its coordinate, its y coordinate or its x coordinate would be alpha. A cosine is related to the x coordinate or the y coordinate. You remember that we have learned that a point moving on the unit circle will have coordinates which are cosine theta and sine theta. So the cosine is always related to the x coordinate or the y coordinate. It is related to the x coordinate. So this is just an angle that has an x coordinate equal to alpha. An x coordinate equal to alpha. This is an x coordinate equal to alpha. This is the x. So what are the angles that have an x coordinate equal to alpha? Initially we'll have these two angles. This one angle and this is another angle. But what about this lower angle? May I state that this angle could be a cosine inverse? No, it is not. It doesn't belong to the first or the second. So I will just eliminate this angle. I will just reject it. Okay? So a cosine inverse alpha can be depicted as this angle. This is exactly the cosine inverse alpha. Now in a similar manner I need to depict this angle. It is a cosine inverse angle which would be in the first or the second quadrants and has an x coordinate but equal to negative alpha this time. Equal to negative alpha this time. This is negative alpha. What are the angles that may be on the first or the second quadrants and have an x coordinate equal to negative alpha? Yes, I have this angle. An angle must be measured. An angle always starts. Does it start? This is the meant angle? No, this is not how I express the angle. An angle always starts from the positive x-axis. So this is the angle. That red angle is just the cosine inverse of negative alpha. Okay? So these are these two angles. Now what is the relation between these two angles? If you have a closer look, you will find this black angle has just a symmetric angle on the other side. an angle which have just a similar value on the other side, that green angle. Okay? Now if you notice that the green angle plus the red angle, what would be the value of the green angle plus the red angle? To just be equal to that red angle plus that green angle. The result is just pi. The result is just pi. This is just pi. Okay? But the green angle is just the same, have the same value of cosine inverse alpha. And the red angle is just the cosine inverse of negative alpha. So now I have this rule that cosine inverse negative alpha is just pi minus cosine inverse alpha. So you just have this rule, which is cosine inverse negative alpha is just pi minus cosine alpha. And this rule must be memorized. You must memorize this rule. So if I need, for example, to find the cosine inverse of negative 1 over root 2, this is just pi minus cosine inverse 1 over root 2, and so on. Now let's move on to study the tan inverse function. We just learned how to find inverse of other trigonometric functions, and they will just be in a similar manner. Okay, so we have this is the graph of tan x, which is like this, and it is obviously not a one-to-one function, so we need to restrict our domain. What would you expect the restricted domain for tan x would be? Tan x restricted, it will be from negative pi over 2 to pi over 2. Yes, this interval is just suitable for us to be a restricted domain. It covers the whole domain and it is one-to-one in that interval, so it is more than suitable for us. So the restricted domain will be from negative pi over 2 to pi over 2. Now there is something wrong that I've written in this restricted domain. What do you think? Yes, they must be open. Negative pi over 2 and pi over 2 are not in the domain of tan, so they couldn't be in the domain of tan inverse, of the restricted tan. So that would be open interval, and the boundaries of that interval are not included in our domain. Okay? We have learned that these two are called asymptotes of a function, which the curve, the curve approaches the asymptote, but it never touches it. It never touches the asymptote. So for the inverse function, let's graph the tan inverse. Instead of vertical asymptotes, we will have horizontal asymptotes. So these are from negative pi over 2 to pi over 2. And the function will just be like this. That is tan inverse x. That is tan inverse x. So what is the domain of tan inverse x? What is the domain of tan inverse x? Are there any restrictions on the input of the tan inverse? No, I may put any value as an input for a tan inverse. So the domain is just all the real numbers. The domain is just all the real numbers. What about the range of tan inverse? What about the range? What are the all values of the outputs? The outputs of the tan inverse are included in some interval. What is that interval? It was just the restricted domain of the restricted tan. It will just be from negative pi over 2 to pi over 2 with open. Okay, that is the range of a tan inverse. That is the range of a tan inverse. What about the symmetry of this function? Is it even or odd? It is an odd function. Yes, it is an odd function. So tan inverse of negative of any block, it will be just negative of tan inverse that block. And I just told you that the rule. There is a general rule that an odd function, its inverse, the inverse of an odd function is an odd function. The inverse of an odd function is an odd function. So a restricted tan is an odd function. So its inverse will also be an odd function. Now he is requiring me to find the inverse of a given function y equals 5 sine 2x plus 1 with a suitable restricted domain. If I give you the problem like this, find inverse of y equals 5 sine 5x plus 1, what would be the answer immediately? If I give you find the inverse of 5 sine 5x plus 1 without that statement, what is the inverse of this function? It has no inverse. Yes, it is not one-to-one. So the answer for this problem will I'll just say it has no inverse. Why? Because it is not one-to-one. Okay? But he's stating in the problem with a suitable restricted domain. So he is just mentioning that you may use or may restrict the domain, so it is one-to-one in that restricted domain. Okay. To find an inverse, we learn to interchange x and y and then solve for y. Or I have told you that it's better whenever the function is not one-to-one. So let's make it in the inverse order. I will just solve it for x first, then in the last step I will just interchange x and y. They are just equivalent steps or equivalent order for our steps. Instead of interchanging first for x and y and then solving for y, I will just first solve for x, then in my last step I will just interchange x and y. Okay, so I just need now to solve for x. What is meant to solve for x? It means that to put x by itself on a side and all the other variables on the other side. Okay, so I have now y equals 5 sine 2x plus 1. I need x to be alone in one side. So I'll just first get rid of this 5. I will just y over 5 to be sine 2x plus 1. Now I need to get rid of this sign. How would I cancel this sign? By operating its inverse function. By operating the inverse of its function both sides. Okay? So, but first I need this to be, to get rid of it, I need to operate an inverse function on it. But what is the condition for this function to have an inverse? It must be first a restricted sign, not a natural sign. It must first be a restricted sign, not a natural sign. So, to get rid of this function, or to say this step, I just need first to state that this is a restricted sign, and the restricted domain would be the input of that sign must be from negative pi over 2 to pi over 2. And that was the restricted sign. The restricted sign had a domain, or had a restriction on its input to be from negative pi over 2 to pi over 2. So that is our restricted domain. If you solve this inequality, this is exactly our restricted domain for this problem. This is our restricted domain for our problem. Okay? Just let's continue to find x. I will just say that 2x will be equal to sine inverse y over 5 minus 1. Then x will be just half of sine inverse y over 5 minus 1. Now I will just interchange x and y. I will just interchange x and y. So y will just be equal to half sine inverse x over 5 minus 1. That is exactly the inverse of the given function. That is exactly the inverse of the given function. The domain of the function itself, or the inverse? The domain of the inverse. What is the domain of this inverse? It is just what are the restrictions on this function? I just have a restriction on the input of a sine inverse. A sine inverse, for the input of a sine inverse, it must be from negative 1 to 1. So x will be from negative 5 to 5. So that is the domain of the inverse, which is exactly the range of f. It is obvious from this case. This is exactly the range. Yes, I have an amplitude of 5. So our range, instead of being from negative 1 to 1, it will be from negative 5 to 5. And that is exactly the range of our problem. But the advantage of this, of using this order for our solution, solve for x first, then to interchange to y for x, that the restricted domain will be obvious for us. The restricted domain will be obvious for us. If you solve it in the other order, the restricted domain will be on y, and that is not, may put you in some confusion. But in this way, the restricted domain, it will be obvious to be, for example, for this case, it will be 2x will be from negative pi over 2 minus 1, negative pi over 2 negative 1, and then divide by 2. Okay, so that will be restricted domain. Another problem. Find inverse of y equals tan inverse x cubed. Y equals tan inverse x cubed. Now this is an inverse function by itself. By nature, this is an inverse function. So it is 1 to 1. So I just solve the problem in the standard way. I'll just interchange x and y, then I will solve for y. or you may solve it in the other order. It is just the same. But the other order is just more suitable if the given function is not one-to-one. So that I need to make some restriction of the domain. In that case, I will just interchange the order of my operation, of my procedure. Now for this function, x will be equal to tan inverse y cubed. I need to solve for y. I will just need to cancel the effect of that tan inverse. I will operate with, what is the inverse of tan inverse? This is the restricted tan. So tan restricted operating on x will just be equal to y cubed. But now I need to find the y. I need to find the y. To find the y, I will just need to cancel the effect of this cubing. What cancels the effect of cubing? The cubic root. So that will be y will be equal to cubic root of restricted tan. And that is exactly the F inverse. Okay? If the problem was y equals to tan inverse x squared instead of x cubed, in this case that function will not be one-to-one. Tan inverse by itself is one-to-one, but because its input is a function that is not one-to-one, x squared is a not one-to-one function. So because we have the input of that tan inverse is not one-to-one, the whole function by itself is not one-to-one. So if I need to find the inverse of this function, and this function is not one-to-one, I will just first solve for x. This is because this function is not one-to-one. So I will interchange the order of my procedure. I will just solve for x first. Then in the last step, I will interchange x and y. To solve for x, I need to get rid of this tan inverse, which I will get rid of it by a restricted tan. This is a restricted tan operating on y equals x squared. Now, to get rid of or to cancel the effect of squaring, I need to operate with a square root. But if you remember that the natural squaring doesn't have an inverse. In order to have an inverse for the squaring, it must be first that x squared must be first a restricted x squared. So to get rid of that squaring, I will just put a restricted domain on this x to be greater than or equal to 0. I will just put that condition so that I can cancel the effect of the squaring. To cancel the effect of the squaring, I need to restrict the x squared first and make it x greater than or equal to 0. In that way, I'll just say that x will be equal to square root of tan restricted of y. And this is my restricted domain in this case. This is my restricted domain in my case. Now I've just managed to solve the problem for x. I'll just interchange x and y. So that will be y will be equal to root of tan restricted of x, like this. Root tan restricted of x. And this is under the condition that the restricted domain, what is the restricted domain of this function? It is x greater than or equal to 0. But by itself, if I didn't mention you to find it for a suitable restricted domain, this function is not invertible. This function is not one-to-one. It is obvious that I needed to make some restriction. Whenever I have a function that I need or that I must to put an restricted domain to find an inverse, so that function is not one-to-one, or doesn't have a naturally this function doesn't have an inverse. But I have managed to restrict the domain so that it has an inverse. So in this case, this function is an invertible function. This function with that imposed domain is a one-to-one function, and it is invertible, and in this case the inverse will be in this form. In this case the inverse will be in this form. If I ask you what is the domain of this function, of the inverse function, the domain of the inverse function, this one, let's put this one. What is the domain of this one, of this function? This is tan restricted, so in this case x will be from open negative pi over 2 to pi over 2 open. And so will be the domain of this function. The domain of this, that will be also from negative pi over 2 to pi over 2. What about this condition? No, this condition is for that function. That is the domain of f, which would be the range of this function. Yes, that would be the range of this function. It will be from 0 to infinity. The range of this function will be from 0 to infinity. Now if I have this problem, cosine inverse this function sine x over x cubed, and I need to find the symmetry of this function. Is it even or odd? I've learned that I have two main rules for composition of functions. If the inside function is even, if this function, the inside function or the input function is even, then the result will be even whatever was f. Whatever was f. If I have f, if the inside function is odd, then the result will be as f. The result will be as f. So for this function, I have this function inside the cosine inverse. I know the cosine inverse by itself is general. I've known the cosine inverse by itself is general. But let's check the input function. I have a rational function which has the numerator and denominator. The sine x by itself is an odd function, so I just put a negative. And x cubed is also an odd function, it will be negative. So the whole ratio will be an even function. So now I have cosine inverse of an even function. So what would be the result? It will be even. We have learned that if the insider function is even, the whole result will be even whatever was the kind of f. Whatever was the kind of f, so that given function is just even. What about this function? Tan inverse of cosine inverse x squared over sine inverse x. Again, this sine inverse is just an odd function. What about cosine inverse x squared? Cosine inverse x squared, this is general, but it has an insider function which is even. So if the insider function even inside a general function, the result will be an even function. So that whole function is just even. So that's why all of this ratio will just be an odd function. So I have tan inverse of an odd function. What is the tan inverse of an odd function? Tan inverse by itself is odd. So that will be odd. So whenever I have an outsider function is odd, the result will be as just f, the outsider function. Remember that tan inverse of odd, this is not a multiplication of functions. No one says to me that this is odd times odd. No, this is not time. This is composition of functions. A function which is inside another function. A function which is inside another function that has a different set of rules than the rules of multiplication and division. These are different concepts from the multiplication and division. That is a function of a function. A function of a function. And in that case, when the insider function is odd, the result will be as the outer function, which is in this case will be odd. Okay? لا ما فهمتش سؤالك، قولي تاني. Cosine x, the cosine inverse x, cosine inverse x squared. This is even, or cosine inverse general. General of even is even. لا كوزاين انفرس اكس دي على بعض ايه؟ دي اسمها فانكشن فوق، مش الايكويشن. دي مش ايكويشن. دي اود. دي اود. اكس كيوبد اود ولا لا؟ هو الفوكس مش حلو في I just need to ask you a question. Is sine inverse x is 1 over sine x or not? Is sine inverse x 1 over sine x or not? No, these are different concepts. A sine inverse x, this is not a power. We learned before that sine squared x is sine x all squared. Yes, that is correct. But sine inverse x is not sine of x all power negative 1. This power, or that when you put negative 1 in the power, this is just a symbol for the inverse operation. It is not interpreted as a power. Okay? This symbol is reserved for the inverse operation, not the power. Okay? So in this case, but any other number instead of negative 1, it will just be a power. So when I say that sine negative 2 of x, so that is sine x or power negative 2. Okay, but negative 1 is just reserved for the inverse operation. Okay, so this is not 1 over sine x. Okay. What about saying that sine inverse 2x is sine inverse x over cosine inverse x? Is that correct? No, if I told you that sine inverse 2x is 2 sine inverse x times cosine inverse x. Is that a correct statement? No, this is a wrong statement. I can take trigonometric relations and just put an inverse on them. that is not permitted. To take, for example, that sine 2x is 2 sine x cosine x, and you just say that if I put an inverse it will be correct. No, this is wrong. Okay? Also, I meet just some students that say that tan inverse x is just sine inverse x over cosine inverse x. Is that correct or not? Tan inverse x is sine inverse x over cosine inverse x. No, this is a wrong statement. I can't take statements from trigonometric function and just put an inverse. This is a correct statement, okay. But I just can't put an inverse for, it is not a power. The inverse is not a power. Okay? So I can't just put an inverse on trigonometric relations. What about this statement? Sine of sine inverse x. Yes, we have just learned that these two functions oppose the effect of each other. These two functions oppose the effect of each other. So the result will just be x. But this x must satisfy the original domain of the given function. We have learned before that simplifications change the domain. So whenever I make some simplification, I need to reserve the original domain of the function. So what is the domain of this function? X must satisfy the condition of a sine inverse to be inside. For this x to be inside the sine inverse, it must satisfy the condition of a sine inverse. What is the condition of the input of a sine inverse? It must be from -1 to 1. So that x is not the natural x. It is the x which is imposed, which has an imposed domain from -1 to 1. If I sketch that function will just be from -1 to 1 like that. That function will just be sketched like that. And that is different from the natural x, which is from -infinity to infinity. These are two different functions. The natural x and that x, which is sine of sine inverse x. These are two different functions, okay? What about this function? Sine inverse of sine x. Sine inverse of sine x. I'll just ask you, when would it be x? When would it be x? When would I say that this function opposes this one or cancels the effect of that other function? When these two functions are inverse to each other. So for these two functions to be inverse of each other, that sign must be first a restricted sign, not a natural sign. That must be a restricted sign. So for the result to be equal to x, that x must be satisfying the condition of a restricted sign. What is the condition of a restricted sign? From -pi/2 to pi/2. That is the restricted domain of the sign. That is the restricted domain of the sign. Okay? But if you look at this function, do I have a condition that restricts me from putting an x which is outside that domain or not? Would I put here x equals to pi, for example? Can I put, does this expression doesn't state that this sign is the restricted sign. It is a natural sign. This sign is just a natural sign. So it permits any x to be an input, to be as an input. A natural sign has a domain of R. So I may receive any input. I may receive any x as an input. In this case, for example, if I had sine inverse of sine pi, or let's put it Sine inverse of sine 3 pi over 2. Let's make it like this. That function is outside this domain. What would be the result of this statement? Sine inverse of sine 3 pi over 2. Would it be 3 pi over 2 and these two will cancel each other? No. Because this statement, the result will be x only for the restricted domain. But if you get outside the restricted domain, the result will be different from x. The result will be different for x. It would be a modified version of x. It would be a modified version of x, so that result is wrong. I can't cancel these two with each other. No, I can't do that. Why? Because 3 pi over 2 is outside the restricted domain. What about the result of this statement? Let's find the sine of 3 pi over 2. Sine inverse of 3 pi over 2. 3 pi over 2 has a sine of negative 1. What is the sine inverse of negative 1? We learned to take out the negative. And what is the sine inverse of 1? It is just pi over 2. So the result of sine inverse of sine 3 pi over 2 is just negative pi over 2. What is the relation between that result and the input, which was 3 pi over 2? It is, if you look at this on the unit circle, 3 pi over 2 is that angle, but it is measured like this. Negative pi over 2 is the same angle but measured this way. So how would you find that x? That x is just, if you take that x and subtract 2 pi. So the result is a modified version of x in this case. And every time you move out of the restricted domain, you will have a modified version of x for this statement. This is exactly what happened for root x and the squaring operation. We know that the squaring restricted has an inverse operation of root x. Okay. So we learned that root of x squared, the inverse, that is the inverse function operating on the function itself. X squared, this is the natural x squared. This will give a result of x only for the restricted domain of x squared. But whenever you get outside the restricted domain, for example, if I put a negative value for x, in this expression, for example, negative 3 all squared, it will give me root 9, which will give me 3. What is the relation between the output of this function and the input? It was negative x. So for a negative value of x, the result would be a modified version of that x, which is, in this case, would be negative x. And that function which we denotated to be the absolute of x. Okay? So every time I have a function with a restricted domain, a function like this, f inverse of f of x, and that function was not one-to-one, and that function is not one-to-one, and I'm operating with the inverse of the one-to-one version of it, or the restricted version of that function. In that case, that statement will just be x only for the restricted domain. But if you go outside the restricted domain and you apply this statement, you will get a modified version of x, such that the result of this statement will satisfy the output of the inverse function. What do I mean by that? Now, what is the output of a sine inverse? It must be an angle from negative pi over 2 to pi over 2. So the angle which was 3 pi over 2 have been modified I just found an equivalent angle which is from negative pi over 2 to pi over 2. So I modified that x to satisfy the output to be from negative pi over 2 to pi over 2. And that exactly what happened to the root x. If I put a negative value in x, that x is modified so that the result of that function, I know that the output of a root must be positive. So I just modified the x so that the output would be positive. The output of f inverse of f of x, the output of this function must satisfy the output of the inverse. So that is a modified version of x such that the output satisfied the output must satisfy the condition of the output of an f inverse, of the range of the f inverse. For example, if I say sine inverse of sine 3 pi over 4. Would the result be 3 pi over 4? Immediately or directly, that is not the result. Why? Because 3 pi over 4 is not included in the restricted domain of the sine. This is not included in the restricted domain of the sine, which is in the first or the fourth quadrant. But how to find the result of this one? I will just modify that input so that the output would be an angle from negative pi over 2 to pi over 2. How would I do that? Let's depict that angle on the unit circle. That angle is 3 pi over 2 or over 4. That is that angle on the unit circle. Okay? I just need to find another angle, another equivalent angle, which belongs to either the first quadrant or the fourth quadrant, but has the same sine value, which means have the same y coordinate. Which angle does have the same y coordinate, but in the first or the fourth quadrant? I have this other angle on the other side. This have the same sine. So the result of this angle would be that red angle. The result of this will be just pi over 4. The result of this one will just be pi over 4. It is a modified version of that input such that it satisfies the output of the sine inverse, which it must be from, it must be in the first quadrant or the third quadrant. Okay? What about this statement? Sine squared of sine inverse 2x. Now this is sine squared. I will just write it again, but sine of sine inverse 2x all squared. We have learned that these two may cancel each other. These two functions may cancel each other. I will have 2x all squared. But for them to cancel each other, these 2x must satisfy the restrictions on the input of a sine inverse, that must be from negative 1 to 1. Must be from negative 1 to 1. So this function is a function from negative half to half. This function have an imposed domain of negative half to half. Also, if I have this function sec of cosine inverse x, sec of cosine inverse x is 1 over cosine of cosine inverse x. For these two functions to cancel each other, I'll just have 1 over x. So I have to find that x to satisfy the restriction of an input of a cosine inverse, which would be from negative 1 to 1. And also it must be this x is in the denominator, so it can't be equal to 0. So this will result in this, will have this result with this condition. X is from -1 to 1 and x is not equal to 0. What about this problem? Tan of cosine inverse x. Tan of cosine inverse x. Now for this function, this is a typical kind of problem. If I have an inverse function inside a trigonometric function. Inverse function inside a trigonometric function. I will just learn now how to treat this kind of a problem. We have learned that an inverse function is just an angle. So I will just denote it with some symbol alpha, for example. Then I will put that alpha in a triangle. Alpha, and I know that alpha is just cosine inverse x. That's why cosine alpha is just x. X over 1. I will just put that on, depict that on the triangle. Cosine alpha is just x over 1. Then I complete the right triangle to be 1 minus x squared. So that is the triangle of the alpha. What do I need to calculate? I need to calculate tan of alpha. Can I calculate tan of alpha? Any trigonometric function. Whenever I have the triangle of alpha, I may find the trigonometric function of any, the value of any trigonometric function of alpha. Whenever I ask you for tan, sec, cotan, any of the trigonometric functions, whenever I have the triangle of the alpha, I may ask you for any trigonometric function for that alpha. Okay? So I need now to calculate tan alpha, which will just be equal to the opposite, the ratio between the opposite, which is 1 root 1 minus x squared over x. So that is tan alpha. That is tan alpha. Now what about this sine of 2 sine inverse x over 2? I need to simplify. He's asking me to simplify this expression. Just as I have told you, I have here an inverse function. An inverse trigonometric function is just an angle. An inverse trigonometric function is just an angle. So I just denote it as alpha. And I need to put it as a triangle. I need to find the triangle of that alpha. Now, I have said that alpha is just equal to sine inverse x over 2. That means that sine alpha is just equal to x over 2. I will just depict that on the triangle. How would I depict that? Sine alpha is x over 2, so that will be x over 2 like this. So how would I complete the triangle? That will be square root of 4 minus x squared. Okay, now I have the triangle of alpha. What are you asking me for? You are asking me for sine of alpha? No, he's asking me, this is alpha. He's asking me to find the value of sine of 2 alpha. Now, how would I find the sine of 2 alpha from the triangle of alpha? I need to express that expression in terms of alpha, which are the double angle rules. This sine to alpha is just 2 sine alpha cosine alpha. This is just 2 sine alpha cosine alpha. Now, any of these trigonometric functions are with respect to alpha, and I have the triangle of alpha. So I will just take them from the triangle. Sine alpha from the triangle is just equal to x over 2. And cosine alpha just from the triangle is just equal to square root of 4 minus x squared over 2. So that is the result of that simplification. So that will be equal to x root 4 minus x squared all over 2. Okay? Now what if I ask you to simplify this expression? Simplify sine inverse of cosine x. Sine inverse of cosine x. Now this is a case which is different from the previous cases. In the previous cases, we have noted that the inverse function is inside a trigonometric function. Either in this case or in the previous, we had the inverse function inside the trigonometric function. But in this case, I have the trigonometric function inside the inverse function. How would I deal with this problem? In this case, I will just use 3 known rules, which are that cosine of pi over 2 minus x is just sine x, and sine of pi over 2 minus x is just cosine x, and so on. Tan of x pi over 2 minus x is just cotan x. Whenever I have a co here, I will just remove the co on the other side. Whenever I don't have a co here, I will just put a co on the other side. So if I have tan pi over 2 minus x, it will just be cotan x. And so on. If I have sec of pi over 2 minus x, it will just be cosec of x. And so on. Whenever I have a co on the side, for the other side, I will just remove that co and vice versa. So these rules are important. I will use these rules in problems like this. I will just express the trigonometric function in terms of the inverse of that function. So I need to express that cosine in terms of sine. I need to express that cosine in terms of sine. So that expression is just sine inverse of sine of. What would I put in that? We have learned that cosine pi over 2 or the sine of pi over 2 minus x is just cosine x. The cosine x can be written as, I can interchange cosine to be a sine, but of pi minus 2 over x. Where did these rules come from? They just came from the right triangle. If this angle is x, so that other angle will just be pi over 2 minus x. And if you just look at this triangle, the cosine of that black triangle is just the sine of that other triangle, the red triangle, the red angle. The cosine of that black, the sine of that black angle is just the cosine of the red angle, and so on. The tan of the black angle is just the cotan of the red angle, and so on. All of these rules just come from a right triangle in this way. So if I have just expressed the cosine x as sine pi over 2 minus x, that in that case I will just say that the result would be pi over 2 minus x, and that is correct only for pi over 2 minus x in the restricted domain of sine. That is, I just can cancel these two by each other only for the restricted sign, which is from minus pi over 2 to pi over 2. But remember, I may put a value that is different from the restricted domain, that is not included in the restricted domain. But in that case, I will not have a value like this. I will have a value that satisfies the output of the sine inverse. I will have a function that will just try to, on a computer or an inline website, you can graph this function. Try to graph this function or this function. Try to graph this function. The output of this function must be must satisfy the range of the sine inverse. The result will be always from negative pi over 2 to pi over 2. So this function must have a result which must be from negative pi over 2 to pi over 2. Try to graph it at home. Try to find a graph of this function or this function at home from an online website or so on. Now for this function, for example, I need to simplify this expression. Sine inverse of 2 sine 4x cosine 4x. In this case, I have the trigonometric function inside the inverse function. That's why I need to express that using sine. Can I say that that expression can be a sine of some angle or not? Yes, this is the sine of 8x. Yes, so the result of this one will be 8x for the x's which are inside the restricted domain of sine only. But if I move outside the restricted domain, I will have a modified version of that expression, such that the output will be always from negative pi over 2 to pi over 2. That 8x is from. What about this expression? Cosine inverse of 1 minus 2 sine squared 3x. Now in this case also I have the trigonometric function inside the inverse function. So I just consider how to express that function in terms of a cosine of some angle. Could I express that expression, or can I put that expression in terms of a cosine of some angle? Yes, I know the rules of the double angle relations, and this is one of them. That is exactly the cosine of the double angle. That is exactly the cosine of double angle. So that expression is just the cosine inverse of cosine 6x. So that will be 6x for 6x, satisfying the restricted domain of the cosine which is from 0 to pi. And outside the restricted domain, I will have a modified version of that x. Consider if you need for any calculation and you need to find the value of, for example, sec inverse of 2, and you have a calculator. In the exam we don't have a calculator. The calculators are not allowed in the exam, but I'm just checking a case. You need in a mechanics in some mechanics problem or a physics problem, you need to find the value of sec inverse 2. If you look at your calculator, you will just find that you can calculate sine inverse or cosine inverse or tan inverse. These are just the inverse values that I can calculate in the calculator. But I don't have sec inverse or cosec inverse or cotan inverse. I don't have these on the calculator. So if I needed in any application that I need to find the value of sec inverse 2, how would I find that value? Now remember, any suggestions what would be that value? Would it be 1 over cosine inverse 2, for example? No. I've just told you that trigonometric relations are not applied in inverse relations. I know that sec of some x is just 1 over cosine x, okay. But is sec x is just the reciprocal of cosine inverse x? No, this is a wrong statement. But how would I calculate sec inverse of 2? Now remember that this is just an angle. Any inverse trigonometric function is an angle. And any angle has a triangle. So let's depict that on a triangle. If I have this angle which is alpha, and I know that sec inverse 2 is alpha is just sec inverse 2, and I know that sec alpha is just equal to 2. Sec alpha is just equal to 2. Can I depict that on a triangle or not? Yes. That is just 2 over 1, and that would be root 3. Or in another way, without using the triangle, sec alpha is just 2. It means that cosine alpha, which I can manage to find its inverse, cosine alpha will just be equal to half. I just made the reciprocal of both sides. And that means that alpha itself is just the cosine inverse of half. So, in this way, what is the sec inverse of 2? It is just cosine inverse of half. Cosine inverse of the reciprocal. Okay? Now, if I told you find the value of cotan inverse of 3. If you have learned that, if you understood what I've made now, you can now put it on any of these cases. You just find the reciprocal of the value inside, and that function is just the reciprocal of that function outside. So if I need to find cotan inverse of 3, what would it be? It would be tan inverse of 1 over 3. It is not 1 over tan inverse 3. No. It is cotan inverse 3. It is just the tan inverse of 1 over 3. Okay? And so on. If I need to find sec inverse of 5, that is exactly cosine inverse of 1 over 5. Okay, so let's write the rules that if I need to find sec inverse of some x, that will be cosine inverse of 1 over x. If I need to find cosec inverse of x, that would be sine inverse of 1 over x. If I need to find the value of cotan inverse of x, that would be tan inverse but of 1 over x. Okay? So these rules also are important for us. You need to memorize these rules. Okay?